Hi again. Welcome to energy and temperature and the relationship between the two. In this lesson, we're going to talk about temperature and how it's an indicator and that it helps guide us and helps us to know where energy is going. So let's start by defining temperature. Temperature measures the average kinetic energy or the motion in a sample. And how exactly do we measure that? Well, we measure it with a thermometer, and there are going to be three different types of thermometers or three different types of temperature scales that we talk about tonight. So being that energy was in the definition of temperature, let's spend some time talking about energy again and make sure we really know what that means, and then we'll go back to temperature. So what is energy? Energy is the ability to do work. So again, there are many types of energy. There's sound energy, there's electrical energy, there's radiant energy, which is electromagnetic radiation, which includes X-rays, microwaves, radio waves, visible light, etc. And we spent some time in class talking about many different types of energy. But all in all, energy for our course, we're going to talk about and think about, we're going to break it up into two main types of energy. We're going to break it up into kinetic energy and potential energy. So kinetic energy I've highlighted in yellow because that's the first one we're going to talk about. And don't forget, kinetic energy is in the definition of temperature. So let's look more closely at kinetic energy. And kinetic energy is the energy of motion. And for our purposes, again, kinetic energy talks about the fact that atoms and molecules are always in motion. So if we look at this drawing or this sample of atoms and molecules, let's just say it's a gas, and some of the molecules that are in motion are in forward motion. So they're zipping around. Others are just vibrating. And some might spin through like the way a baseball spins. But notice all of them are in motion, and some might collide with one another and they could totally halt a molecule or an atom. And then that would have no temperature, because temperature is the measurement of the motion of the particles. So if they're not moving, then they don't have a temperature, and we'll talk about what that means later on. But atoms and molecules are always moving. So please understand that atoms and molecules are in motion, and some will have a lot of motion, and some will only have a little bit of motion or only have a little bit of energy. So each atom and molecule has a different amount of energy. So when you look again at the picture, you can see that some have a lot of motion, some just a little bit. And what this results in when we talk about kinetic energy, it's the average of all the particles in the sample that gives us the temperature. And that's very important for you to understand. So now when you know the definition of what kinetic energy is, and that it is the average of all of the molecules and the atoms moving, you look at the definition of temperature, and again it says temperature measures the average kinetic energy or the average of the motion of the particles in a particular sample. So this right here shows you, this is a model to represent how you have the molecules or the compounds moving at different rates. Some are moving very quickly, and yet some are moving slowly, and it all depends on how they bounce into each other and the directions that they move and the manner in which they move. But so temperature does not mean that every single particle is moving with the same rate, rather that it's so instead temperature is the average kinetic energy of the motion in the sample, and that model truly represented that. So now that we've elaborated on the definition of what temperature is, let's go back to how do we measure it and the different types of thermometers and the different types of systems. So as Americans, we're accustomed to seeing things in Fahrenheit. Weather reports tell us Fahrenheit. But in our course in chemistry, we're going to be using the degrees Celsius. It is the metric unit, and it was based on properties of water. when they were establishing the Celsius scale, they paid attention and they watched when the temperature in the thermometer stopped dropping and the liquid water changed to a solid. That occurred at 0 degrees Celsius. And when the liquid water, when the temperature on the thermometer stopped and the water went through a phase change and turned to steam, that's what they designated as 100 degrees Celsius, as boiling. So let's continue to talk about the fact that 0 represents the average kinetic energy and 100 represents the average kinetic energy. The 0 of when the water, we're saying it's frozen, and when the 100 represents when the water is boiling. Now, just because water is frozen doesn't mean those molecules aren't moving some. They're vibrating in the solid phase. So if we think about this, at some point, theoretically, there should be a point where molecules don't move at all. And so when we have the Celsius scale, it can go into the negative range. So when it gets to the point where there are no molecules moving at all, we call that absolute 0. And that is something that an entire scale, the Kelvin scale, was based on. And that is how the Kelvin scale compares to the Celsius scale. So when we look at the 3 scales together, side by side, you have the Fahrenheit scale, something that you are accustomed to in your everyday life, talking about water boiling, 212, water freezing, 32 degrees Fahrenheit. You've heard this before. You might be saying, oh yeah, I have heard that. And the point that we just spoke about, where no molecules at all are moving, and again, if temperature measures the point, the average kinetic energy when molecules are moving, the point when they're not moving on the Fahrenheit scale would be minus 460. Now, when we look at the Celsius scale, this was a scale that we said was nice because it was based on water, and water boils at 100 and freezes at 0, and there are 100 separations in between the 0 and the 100, and that theoretical point that they have confidence in that molecules will stop moving is minus 273 Celsius. The Kelvin scale starts at 0 because that's what they're saying is absolute 0. But it does have the same exact increments as the Celsius scale. So when you create a conversion factor between Celsius and Kelvin, because we will have to use Kelvin later on this year, I will show you and write down the conversion factor for that. So it makes sense based on what we said that you would take your degrees Celsius, add 273 to them to get your temperature in Kelvin. That's how you convert. And we did this in our activity in the beginning of the year. So Kelvin equals degrees C plus 273. This right here, I copied and pasted directly off of table T. It's the last piece of information on table T on your reference tables. So I think that wraps up what is temperature, what is energy, and what is the relationship between energy and temperature. Be sure to bring any concerns or questions you may have into school. See you soon. Bye.